So this week we're going to discuss the so-called multiphase flowing material balance feature inside of Whitson Plus. That's a module that resolves the pore volume and the oil, gas, and water in place numbers from this type of straight line analysis that you see to the right here. Before we go into the details of the module itself, it's important to discuss what's unique about this method. And probably what's the most unique about this method is that it does not require relative permeabilities as an input. The reason for that is we're using only historical rates, where all those ratios are baked in to the rates themselves. So we actually don't need relative permeabilities. The details of the theory we'll skip today, but what's unique compared to existing methods is that existing multiphase flowing material balance methods, they require both relative permeabilities, and they also have a diagnostic plot that's very, very hard to interpret. So it typically looks like a gunshot. This new multiphase flowing material balance method does not require relative permeabilities. It has a diagnostic plot that's easy to interpret. And it's also tested on hundreds of field cases and simulated data, so we know it works. And it was developed by Simrex or Quotera from 2017 to 2021. And in all simplicity, the slope that you saw in the diagnostic plot in the software itself, that's just inversely proportional to the pore volume. So you use that to estimate the pore volume, and you use that again to both either anchor your decline curve analysis if you link it to a recovery factor feature, or you can use it to bound, for instance, your numerical models. And so this module is available in Whitson Plus. It includes intuitive drag and drop functionality, and it automatically at the same time calculates the average pressure for that tank size and associated saturations. So it's nice in that sense. And you can also link it to a so-called recovery factor analysis feature that we'll discuss at a later point in time. But before we actually go and apply this on real field data, we need to be comfortable that this is actually accounting for all the difficult stuff that we see in a multiphase flow environment. And if we go into Whitson Plus, the example that we're looking at now is a synthetic case. The reason why we use a synthetic case is that for a synthetic case, which in this case is this case, we know all the inputs. So here you can see that I've included some matrix relative permeabilities. So of course in the numerical model, when I create this numerical case, I need to have some relative permeabilities as an input. I need to have some PVT and some fluid initialization data, and I also need to provide some well and reservoir data. And once I've run this particular feature, you see that there's essentially a lot of things going on here. First of all, you see that we have changing bottom hole pressures versus time. We have a changing GOR profile or a CGR profile versus time. And we also see that we're producing three phases. So this is a classical multiphase flow type of example created with a full physics numerical model where we know all the inputs. So in this case, we should be able to then resolve these original oil in place, gas in place, and water in place numbers. Okay, so if you remember these numbers right here, and we go to the multiphase flow material balance plot right here, you see that they're essentially identical. So 243, 4862, 2146, and then you compare those to 243, 4861, 2178. So very, very, very close in terms of numbers.